a straight line. Let's say there is point A and point B. When I connect those 2 points referring to a shortest distance, the path that I am going to obtain, the path is going to be a straight line. For time being, let's say this is another path, path B, or some random path. This is path C, and if you compare length of those three, we can clearly say that the shortest distance or shortest possible distance is being represented by this straight line. Now, similar to projections of points, this line can be located in any quadrant. Let's say this is quadrant 1, quadrant 2, quadrant 3 and quadrant 4. So line could be like this one, this one, this one, or this one. It could be any possible orientation and located in any quadrant. Even there might be certain cases where the line is located in 2 quadrants, and in all those possible scenarios we are supposed to draw front view of the line and top view of the line, and that is basically a orthographic projection of a straight line. Now there are certain positions of line with respect to horizontal plane and vertical plane that can be generalized. The first scenario is a perpendicular line. Second one, parallel line. Third one, inclined line. And fourth one is inclined line itself, but that inclination is with both HP and VP. In inclined line, or let's say first scenario, perpendicular line is going to be perpendicular to one of the reference plane and parallel to other reference plane. In case of parallel line is parallel to both reference planes, HP as well as VP. When line is parallel to both the reference planes simultaneously. Inclined line, when line is inclined to one of the reference plane and parallel to other reference plane. And the last scenario, oblique line. In this case, line is going to be inclined with both reference planes simultaneously. So when line is inclined to HP as well as VP simultaneously, that line is called as a oblique line. So these are the various possible scenarios. Let's talk about them one by one. For example, this sketch represents a first scenario, that is perpendicular line. Now for time being, we have considered a line perpendicular to horizontal plane. It is perpendicular to this horizontal plane, and you can see it is parallel to the vertical plane. Now in this case, if you draw its front view, that is when you look at the line in this direction, you can see it is going to be a straight line, this intersection of horizontal and vertical plane, it is going to represent our xy reference line. In this scenario, the front view is going to be a straight line which is perpendicular to xy line. Let's say this is a dash and this is b dash, and when you draw its top view, that is when you look at the line from the top direction, this point A and point B are going to be projected at the same location. Whatever distance line is having with respect to vertical plane, same distance has to be considered with the xy line, and at that distance you will get the top view of the line AB. So this is going to be projection of the line when line is perpendicular to HP and parallel to VP. We can reverse this scenario. Line could be parallel to HP and perpendicular to VP. In that case, this front view will be replaced by top view, and this top view will become a front view. So the solution is going to be point in the front view and straight line in the top view. In the second case, a parallel line, that is line is parallel to both HP and VP simultaneously. Now in this case, whether you are looking at the line in the front direction or in the top direction, in both the cases this view of the line is going to be a straight line which is parallel to xy line. So let's consider this as a dash b dash and consider this as a AB. So this is front view of the line and this is top view of the line. The distance of the line from vertical plane will be taken distance of top view from xy line, and distance of the line from horizontal plane will be considered when you draw its front view. That is, front view will be located at that distance above xy line. In case of inclined line, that is line inclined to HP, this is the line, it is inclined to horizontal plane, let's say at theta, and line is parallel to the vertical plane. Now in this case, when you draw its front view is going to be a straight line having certain inclination with xy. That inclination is going to be equivalent to inclination of line with the horizontal plane. So this is front view, and when you draw its top view, we know that front view as well as top view of the point is going to be located on the same line. So the distance of the line from vertical plane, at that distance you will get one straight line parallel to xy line. So this is going to be a top view of the line. Now when you compare length of those two views, the line is parallel to VP, so the view that is going to appear in vertical plane, that is a front view, is going to represent true length of the line, whereas line is inclined to HP, so the view that is going to appear in a horizontal plane, that is top view, is going to have a reduced length. Now against this, if you consider opposite scenario, when line is inclined to vertical plane and when it is parallel to horizontal plane, the solution will be reversed exactly. So now in top view you will get an inclined line, and in front view you will get a straight line which is parallel to xy line. So this is going to be top view of the line, this is going to be front view of the line. This will be reduced length because line is inclined to vertical plane. So view appearing in vertical plane will be of reduced length. Line is parallel to HP. So view appearing in HP will represent a true length. Now last scenario, when line is inclined to both the reference planes simultaneously, that line is going to be called as a oblique line. Now we know that if line is inclined to vertical plane, in this case the front view was representing the reduced length. In previous case, when line was inclined to horizontal plane, the top view was representing a reduced length. Now when line is going to be inclined to both the reference planes simultaneously, in this case
It's 11 hours.
in this case front view as well as top view are going to represent a reduced length. You will not get true length of line in any of the view, front view as well as top view. So when you are solving examples based on oblique lines, there are few additional steps that we need to follow, and that we are going to discuss next. Now consider there is a line AB having length equal to 70 millimeter. Its end A, its position with respect to HP and VP is given. It is 15 mm above HP and 20 mm in front of VP. The line is inclined to HP at 30 degree and it is parallel to VP, and additionally the position of point is located in the first quadrant. Okay, so in this case this is first quadrant, this is HP, this is VP, this is intersection of HP and VP being represented as a XY line. Now from the position of point A, it is above HP in front of VP. Point B specifically stated it is located in first quadrant, so we know that the whole line AB is located in the first quadrant only. So when it is located in first quadrant, we know that the front view of the line will appear above XY line and top view will appear below XY line. Now let's try to imagine the position of the line. Point A, 15 mm above HP, 20 mm in front of VP. So this is point A. This distance is 15 and this distance is 20, and line is inclined to HP at 30 degree and parallel to VP. So as we are representing two-dimensional quadrant system, so we may not be able to exactly represent the line, but it is going to be something like this one. Or if you represent it in a 3D format, this is horizontal plane, this is vertical plane, then line is going to be like this one. It is going to have certain inclination with HP and it is parallel to vertical plane. Now in this case we are supposed to draw its solution. Okay, to draw its solution, First step, draw the XY line. Now, whenever you are going to draw projections of the lines, we need to be clarify this at beginning only, that the first step of solution of projection of line is always going to be projections of a points, or in short, we know that straight line is nothing but when you connect two points with the shortest possible path. So basically you are connecting two points together by referring a shortest path. So this is extension of the projections of the point. You are going to project those 2 points alternatively, and we are going to connect them to represent the line. So line is AB and position of point A is given with respect to HP and VP. So point A is 15 mm above HP. So let's say this is A dash. We know that both front view and top view are going to be projected on the same line. So on the vertical projector passing through A dash, point is 20 mm in front of VP. So below XY line at a distance of 20, you will get the top view of the top view of the point. Now once you have located A dash and A, the first step that you are supposed to do is draw locus passing through those 2 points. Locus is basically a line which is parallel to XY line. Now line is inclined at 30 degree to HP. The relation is with HP, so it is going to be part of front view. So from A dash, draw one line which is inclined at 30 degree. The length of line, the line is parallel to VP. So in front view, you are going to get the true length. True length is 70. So on this line, 30 degree inclined to XY line, this is going to be your front view A dash B dash, and length of this segment will be 70 mm. Okay. Now similar to projections of A, the projections of B are also going to be projected on the same vertical projector. Line is parallel to vertical plane, so its top view is going to be parallel to XY line, and this intersection of vertical projector of the B dash and locus of A is going to be our point B. So this is top view of the line and this is front view of the line. So this is going to be projection of the given line. This example was based on a line which was inclined to one of the reference plane and parallel to other reference plane. Now let's say, or let's discuss what we are supposed to do in case of oblique lines, that is when line is inclined to both HP and VP simultaneously. Now there are two general scenarios. When you have located front view and top view of the line, how to proceed with the solution, that is first scenario. And second scenario, when true length of the line in front view and true length of the line in top view is located, and you are going to locate final front view and final top view of the line, and how to proceed with that solution. We'll discuss that one now. First scenario, when you have located front view and top view of the line. Let's say this is XY line, this is A dash, B dash, that is front view, on the same projector, let's say here you have got the A and here you have got the point B, that is front view and top view of the line, front view and top view of the point, and this is representing a top view. Now to proceed with solution, first draw locus passing through point A dash and A. Next step, keep compass at the point A dash, take a radius equivalent to length of front view and draw this arc, or in short, make it horizontal and parallel to XY line. You will reach over here, project this point vertically downward. Now on this vertical projector, when you take a locus of top view of the B, you will get one intersection, and that intersection is going to be considered as point B2, and when you connect that point B2 with A, this segment is going to represent true length of the line, and that is in top view. Now once you have got true length of line in a top view, to locate true length of line in front view, same, draw a locus passing through B dash. Now you have two choices. The first, keep compass at point A, take radius is equal to AB, that is length of top view, and make it horizontal till this point, it is parallel to XY, and then project it vertically upward till it intersects the locus of B dash, and that intersection point is going to be named as B1 dash, and when you connect that point with point A dash, this is going to represent true length of the line in front view. And another way is, as it is representing true length is going to same in case of front view as well as top view. It is not going to change. So once you have got true length in top view, that is segment AB2, take length of AB2 in a compass, choose center A dash, and the locus that you have drawn through point B dash have intersection with that locus. The intersection point is again going to be B1 dash only. So either you can do that one, or conventionally you can you can rotate the top view and then project it vertically upward to have intersection with the locus of B dash. Both way you can get the same point. So this is the first scenario when front view or top view has been already located. Now let's talk about the another scenario when you have located true lengths. True lengths are represented by A dash, B1 dash, that is true length in front view, and similar to this one, A dash and A are always on the same projector. Let's say this is true length in top view. It is denoted by AB2. Now B dash and B, that is front view and top view of B, lies on the same vertical projector. A dash and A lies on the same vertical projector, but B1 dash and B2 are never going to lie on the same projector. You can see clearly this is the projector of B1 dash and this is projector of B2, and those two are different. So don't expect that those two are going to be on the same projector. Now let's say how you are going to locate the front view and top view. Draw a locus passing through point A dash and A. When you had located front view, you rotated it first and then projected to locate the B2. Now you already have B2 and you are going to locate B dash. So what you can do, project it vertically upward till the locus of A dash, means I have reached this point, and now there will be a locus of B1 dash. Keep compass at A dash, take radius equal to this distance and draw this arc. You will have intersection with B1 dash, and that point is going to be B dash, and this is going to be your front view. Now similar to this case, when you are going to draw top view, that is you are going to look at the point B, again you have two possible choices. The first, similar to what you did with B2, you can project this point vertically downward till the locus of A, keep compass on A, take radius equivalent to this much distance and rotate this point to have intersection with locus of B2 and connect with A. This is going to be your point B and this is top view. You can do this one, or we already know that B dash and B are always going to lie on the same projector. So once you have located B dash, you can simply project this point vertically downward and have this intersection, and you can locate the point B. Both cases are absolutely fine. Okay, so this is the second scenario when you have located true length in front view as well as in as well as in top view, and you are supposed to complete the solution. Now there are some certain important things. I will draw one generalized diagram first. So this is A dash B dash on the same projector through A dash, projector through B dash. Let's say here you have got the point A and here you have got the point. Connect those 2 points. Okay, so this is front view and this is top view. Now when you locate true length first draw a locus through B dash, draw a locus through B, draw a locus through A, draw a locus through A dash, and draw a locus through A. I will change the color for true length. Let's say somewhere here you have got the true length, so this is B1 dash, and somewhere here you have got the B2. So this is true length in front view and this is true length in top view. Okay, now the inclination of the front view, that is A dash B dash with xy, it is denoted by alpha. Inclination of the top view, that is AB with respect to xy, denoted by beta. Inclination of the true length with xy line, that is A dash B1 dash, denoted by theta. Inclination of the true length in top view, that is A B2 with xy, denoted by phi. We need to strictly stick to this convention. When true length was already located, we projected it vertically downward till the locus of A, and then we rotated it to locate the point B, right? Or opposite to that, when front view was located, we made it horizontal first, that is parallel to XY, and then projected it vertically downward to locate this point B2. Both things can be done. Or when true length of top view is located, we can project that point vertically upward till the locus of A and then rotate it to have intersection with locus of B1 dash and locate the B dash. Now the point to be noted is, when you projected this B1 dash till the locus of A, this point is called as B1. This B1 dash is located in front view. You have taken it below XY, so now it has become part of top view. So B1 dash has become B1. In top view, we don't use dash. And same segment, that is A B1, you have rotated. So length of this segment and length of top view are going to be same. So this segment A B1 is called as length of top view. Similar to this, when you project this B2 point vertically upward till the locus of A dash, this B2 has reached in the front view. So B2 will become B2 dash, and length of this segment and length of front view are going to be same, because on rotation you are going to look at the front view. So this segment, that is A dash B2 dash, is called as length of front view. So how many points are there that you need to remember? First, true length of the line. Then it could be length of front view, it could be length of top view, inclination of front view with XY, inclination of top view with XY, inclination of true length with horizontal plane denoted by theta, inclination of true length with vertical plane denoted by phi, and additionally, if segment is or the line is AB, either position of A or position of B. So out of this much data, some data will be given in a question. We need to complete this solution and we need to find the remaining data. So out of those things, the minimum required data will be given in the question. We need to complete this solution and we need to find the remaining data. So ultimately we are supposed to complete this solution. That is, we are going to locate front view, locate top view, locate true length of front view, and locate true length of top view. And once we locate those 4 segments, the solution is considered to be complete.